Hi everyone. So thought I'd do a quick, or at least try to make it quick, video on what I've been doing with my vacation. Got a lot of stuff going on here. So this is basically the Z80 MBC2. Been playing around with the user port. I've got a couple of tack switches, some pull-up resistors, some LEDs, and I got the whole thing hooked up to a Raspberry Pi through a level shifter, which I kind of talked about in my last video. So what this is letting me do is some pretty impressive color graphics capabilities for a terminal that is only fed with control codes. So I thought I'd start off real simple. We can boot it up. And this is outputting with the RCA out port on the Raspberry Pi, but you can do HDMI, and I have done. The quality is really, really nice, but I'm trying to work alongside my full-sized LCD here with the computer hooked up to it, and I can't go back and forth if I have it hooked up to the HDMI. So right now I'm working with the TV again. So been trying a couple of things here. Wrote a couple of programs in Pascal to kind of showcase this thing. So what I'll show you here is, first thing is basically there's a test circuit for the user port. And another person actually wrote a program called Porter. I will link everything down here. So you can go to his website and take a look at all the other stuff he's doing. He's got a breakout board for the one of the, I think the ZX Spectrum. Don't quote me on that, but that was one of the things that he was working on that was also up on there. But this Porter program, which I didn't bother to make a com file, so we have to compile it, but it's not that big of a deal. Alright, so we are in this program, and as you can see, what it does is it kind of cycles through LEDs that are all hooked up in series through this 600 or so ohm resistor. I think it's a 620. It's probably a little low for what I'm doing, but it's working. So what we do here is this works with several bus interface. You can do the Z80 PIO or direct port writes, or it also works with the Z80 MBC's GPIO expander. So we pick 2, and then it asks us which port, because there's 2. We're going to pick B because that's what the LEDs are hooked up to. Press enter, and then we can do here, this one's my favorite. So it's like a little Newton's cradle, and the LEDs just go back and forth. You can actually see he's got delays in there. So you can see the operation LEDs going. and the DMA LEDs going on the main board there. But pretty much this is just done to showcase that the port is working, and you could switch the lines over to the other one. Currently I have tack switches hooked up to that one for another program I'm going to show you guys. So that's that, and then you push a key to stop. He's running through the terminal, so sometimes it doesn't always grab that key. You've got to set a pretty hefty delay on this terminal if you're running things pretty fast through the terminal interface, which I'll show you in a second. So I'm just going to pull the power here and we'll reboot because I want the user port to just be completely reset. This is the boot up screen for the terminal, and it loads up pretty fast, gets you right into there. You don't miss an awful lot of the loading screen from the mini computer, but if you hit the reset line, you can take a look at the iOS statements as they're loading if you need to see those. So next, alright, so we've got a couple of programs I wrote here. First was just a program that cycles through the entire color scheme one at a time and puts color up on the screen. And as you can see, it's going to cycle through all the color modes. So the quality's not that great because it's through the video port, and I'm not sure this is the quietest TV display. But if I get real close, you can see. Well, maybe you can't on some of the colors, but it does go through the full gradient of available 255 colors for the ANSI color scheme. And then I also wrote a program which, anytime you've got capability of doing graphics from some of these 8-bit computers, someone's sooner or later going to write one of these guys. This one here takes an input key from the user, so it's going to run a lot slower. And the reason I did that was to show. So this is all being done with escape sequences. It's writing characters to the screen which you can't see because the computer is not displaying them because the terminal is being told not to do so. But essentially, we can write graphics to 640 by 480. The whole area of the screen using line commands. There's also a command for drawing circles, triangles, and squares, and also a command for filling them in. And the reason that that is important to note is the square draw, circle draw, and triangle draw are only a few bytes of information of where to start drawing, and then it just draws it. So it's very, very fast. Now this doesn't look super fast, and the reason for that is I have put a delay of 60 milliseconds in order to give the terminal a chance to clear some of the character draw routines. These two lines here. The first one picks a color, and the second one draws the line. There's the delay, and then this is the key press statement to pop us out of the loop, and then the rest of the right statements just put the terminal back the way that it's supposed to be. So that's one way of doing it, but I thought, you know, since I've got this general purpose I/O port with the GPIO expander, oops, why not do the whole thing with the user button? Just draw as fast as I can and break out of the loop with the user button. Then that doesn't involve the terminal. I don't have to have that delay. It'll run even faster. And as you can see, it takes a matter of seconds. I think David Murray, the 8-bit guy, did this maybe last year on the maximite 1, or the color maximite, and I think this kind of gives that computer probably a close second run for its money. It's very fast at 8 megahertz for an 8-bit computer. I mean, we virtually filled the whole screen with lines, and in a very short period of time, there won't be any unfilled space. And then to break out, you just press the user button, and it pops us back. Well, I thought, okay, well, let's do one more. So this is the same program that we ran before. It's running at the same speed. There's no delay in there. And I've got these two buttons. So the first button, when you press it, clears the screen. It starts over. And the second button, when you press it, pops us out. You'll notice it says 1. So I put in a statement at the end of the program that outputs what the value of the general purpose I/O pin, or actually the whole port. It's saying 1 because the binary value 1 is what the port returns when it gets a signal on that line. So how the circuit works is I've got two 10K pull down resistors to ground, and the data lines are pulled low, and when you press the button they pop high and it registers a key press. Now I discovered a few things. The first of which is I needed a debounce for these terrible tack switches. And it is about 1.5 seconds. If I didn't put that in, what would happen is it would hit this point in this case statement here, which is 64, which is the first button value, and it would continue to clear the screen even though you had let the button go. So I had to build in a debounce delay. I also built a case for 65, which is what comes up when you hit both buttons. So So when you press the first button, and see how it's clearing the screen because I'm holding it. When you hold them both in, it flashes both buttons on the screen. And actually, there's quite a bit of debounce in there, even though I programmed in the delay, because I put codes in to delay it so that you could see the both buttons message, because it was coming onto the screen so fast and being cleared that it wasn't perceptible. You couldn't see it. So it's actually a pretty cool program. And I think it's neat that you can do all of this just with control codes. So, I mean, obvious, right? The next step is to write a game and hook it up with a NES controller. Well, this is actually, you'll notice, it's an Atari wired NES controller. And this interface actually did not work. I was going off of a test circuit that was in one of the basic programs, and I found out through a lot of testing that it basically just isn't the right way to do it, or isn't the right way to do what I'm trying to do. So the way I figured it out was radically simpler than trying to pull one pin at a time. It's much easier to read the whole port and create a case table for each button press or button press combination. So that's what I'm gonna do when I write the little game. I will probably most likely be porting David Murray's Tetris, which is written in BASIC to Pascal. But we'll see. I might write something else. So the other thing I was going to mention, this bus expander does have internal pull-ups, but they are really weren't working all that great. I was getting floating values all over the place when I was trying to read and write from the pins. So that's why I ended up doing external pull-ups or pull-downs. It just worked out better for me. So I don't know if someone has been able to successfully use a tack switch, and it might just be my switches are terrible, with the internal pull-ups with just wiring the switch to ground and the pin. Let me know in the comments if you've successfully been able to get that to work in Pascal. I'd really like some feedback as to how you coded that to make it work. I get this down to 2 port statements per pole. Really all it does is it pulls the read OP code for that particular port, and it queries it and saves the value. That's it. So it's rather incomplex, and I'm sure I'm going to run into some problems later on, and I'm probably going to have a heck of a time debouncing this. My guess is I'm going to have to do it with circuits, probably. But we'll see. I mean, I might be able to just program a delay. My main concern is, you push the key and then it's so sensitive that your Tetris piece goes all the way to the other side of the screen. And that's obviously not what we want. So, something to think about. Well, I wanted it to be a short video, but now it's about 20 minutes. So I hope you stuck with me. Neat little computer. Check it out if you can. They did actually just port Collapse OS updated the firmware on this thing to get that running. It's a reasonably modern 4th implementation. Sorry about the autofocus. So check that out. I hope you guys enjoyed. I've really liked learning a bunch of stuff about this thing. I will see you guys next time.